Let's look at how we multiply or divide a rational expression. So to multiply a rational expression, you factor first, and that means both numerator and denominator of both fractions, and then cross cancel. And I'm going to say that in parentheses, in quotes again, because cross canceling is not really a good math term, but I know that people know what it means, so I'm going to use it. All right, so let's look at our first one. We have 5p minus 5 over p times 3p squared over 10p minus 10. So I have four expressions, the two numerators and the two denominators. So let's look at the first numerator. I can definitely factor out a 5, giving me 5 times p minus 1 over p, there's nothing I can do with the denominator of the first, times 3p squared is just 3p squared. But this denominator I can also factor by factoring out a 10. Now that everything is factored, just like you cross cancel when you multiply rational numbers or fractions, we're going to do the same thing. So p minus 1 cross cancels p minus 1. 5 goes into 5 once, it goes into 10 twice. This p crosses out one of those, leaving just a p. And now it's kind of hard to see what's left, but it looks like I have a 1 times a 3p in my numerator. And in the denominator, I just have a 2. And so we have multiplied and simplified the same way that you do with fractions. Let's look at the next one. A little bit harder because there's more factoring. First numerator is c squared plus 2c. I'm going to factor out a c, leaving c plus 2. So I factored out a GCF. The first denominator, c squared minus 4, difference of two squares, so c plus 2, c minus 2. It's quite important that you are able to factor and recognize what you're seeing. C squared minus 4c plus 4, that is a trinomial short process, so I'm looking for factors of positive 4 that add up to negative 4, negative 2 and negative 2. So that's going to be c minus 2 times c minus 2 over c squared minus c. We're going to factor out a c. Now, everything is factored, so now we can cross cancel. C plus 2, C plus 2. This C cross cancels that C. C minus 2, C minus 2. And I think the only thing we have left is C minus 2 over C minus 1. All right, one more and then we're going to divide. This numerator, we got lucky here, doesn't need to be factored, but this one does. This is a short process, trinomial, so I'm looking for factors of positive 36 that combine to make negative 12. That would be negative 6 and negative 6. So x minus 6, x minus 6. Let's go to our second rational expression. X squared minus 3x minus 18, another short process. So I need factors of negative 18 that add up to negative 3. I believe that's a negative 6 and a positive 3. Check. It multiplies. Yes. Check. Yes, it adds. So we have x minus 6, x plus 3. And finally, I have another trinomial short where I need factors of positive 12 that add up to positive 7. That is positive 4 and positive 3. So you notice there was a lot of factoring involved in just getting that ready to simplify. Now I can cross cancel any whole unit. So this x minus 6 cross cancels that one. This one cross cancels that one. X plus 3 cross cancels x plus 3. And before you say that the only thing that's left is x plus 4, be careful. Look at where it is. It's in a denominator. So what's left in the numerator? Well, every time one of these cross cancels, we're actually making ones. We're being lazy and not writing them. I'm being lazy and not writing them. So what we have left is 1 times 1 times 1. We have a 1 left. Don't just write x plus 4. It's not the same thing. So your answer here is 1 over x plus 4. To divide rational expressions, we keep, change, flip, just like we do with fractions. Then you factor and cross cancel. So it works the same as rational numbers or fractions. So we have example 2a. Let's go ahead and keep the first, change to multiplication, flip to the reciprocal of the second. Nothing needs factored here. It's all just monomials. So I can just go ahead and cross cancel. 9 goes into 9 once, goes into 18 twice. This z cross cancels one of those. And I think that's it. So in the numerator, we have 2 times 2 is 4. In the denominator, I have 1 times 5z is 5z. All right, let's look at one that does need to be factored. But we are always going to keep, change, flip first. So we're going to keep the first exactly how it is, change to multiplication, flip to the reciprocal of the divisor. So we did this. Now we're ready to factor. So in my numerator, I'm going to factor out an 8, leaving k minus 2. 3k is a monomial, so it can't be factored. 4k squared is a monomial, it can't be factored. But this binomial, I can factor out a 3, leaving k minus 2. Now let's see what pieces of those factored expressions will cross cancel. So k minus 2, and this k cross cancels one of those, leaving just 1. And I think that's it. So we end up with 8 times 4 is 32. K, sorry, there's a k left there, over 3 times 3 is 9.